Hey, we got a slightly different one today. It's a bike light from the old mama cherries they ride here in Japan. Everyone seems to ride the cheap, just general purpose bike. This one sits on the front forks, so your wheel's going this way, and it sits on the front forks. And if you hit the lever, if I got it the right way, yep, you hit the lever and that moves in. Press on the wheel, spins, creates voltage. What is it? A 6 volt, 2.4 watt, and then lights up the light globe. So this one isn't working. I've been tasked by my mother-in-law to fix this for her, or if not, if it can't be fixed, to just replace it. So I'm going to give it a go, see what's going on, see what actually makes this thing tick, and see if we can fix it to make it work again. We might even maybe do a upgrade or two, because it's got a light globe in there. I'm sure I've got some LEDs around I could put in there, and yeah, see if we can try and get this thing operating again. Mama cherries are very common in Japan. Everyone seems to drive them or ride them, but they oh, which way am I going? That way. So a lot of the things are very cheap to replace. Doesn't look like there's much happening there at all. So there is nothing. Let's open this thing up. We should probably test the light globe. It could be something very simple. Or maybe not. So let's test this light globe. Interesting globe. It's got like a frosted sort of glass on it. But it's just a standard sort of torch globe. 6 volt, 2.4 watt, XE. That might be the brand. Japan. Made in Japan. Nice. I'll get some leads and see what this thing does. We'll give it 5 volts so it's not stressing it out. And the light does work. So that's fine. That means it's either the wire. I can actually take that out. That's like a little spring clip there. What I might do is I'll hook up a multimeter to this, spin it, and see if we get voltage coming out, because that will tell us straight away if this is busted or not. Alright, set that to DC volts. It might be AC actually, because it's a dynamo or generator or whatever, but we'll try DC first. Hook that on there, if it will hook on without coming off. Make sure that's in the view. See what happens. Nothing coming out on the DC range. Maybe it's AC. Alright, 2 volts. So we got something coming out. I'm going to get a faster drill and see what happens when we spin it faster. Alright, time for the big one. I'll put it onto high speed, and I'm going to change the leads as well. Get some more clippy leads. That one will go there. Okay, and this one, is there somewhere more convenient? No, just like that. I'll hold that one on there. Alright, we still got the screen on. It will spin that way. We're getting 5 volts out, so it must have been the wire. I wonder if there's a bad connection somewhere. That is maybe to do with this dirty old wire. Let's test that wire. Put on the beep. Is it going to beep? The wire's fine. What could it be? I want to try it again with the faster speed. I'll put that over there like that. Screw that in. Okay, put that in there. That sits on there. Nothing. It must be an open circuit voltage is building up, but once you put a load on it, it drops off. So let's open this thing up. Actually, I'll get rid of the globe holder, the lamp section. If it will let me. No, that's kind of integrated. It's got a stud, not a stud, it's been like riveted kind of. Let's rip this open and see what's going on. There could be like a shorted turn or something in there, or who knows. It could even be completely sealed. It's got some clips as well. Whoop, there goes the spring. One complete turn, I remember that. I guess I want to take that off. Oh. That, oh, is on there tight. Oh, it unscrews. Derp. There's a little washer there too. Oh, there we go. Permanent magnet sitting in the line, in the like a magnetic kind of cage. And we've got the windings there, and it looks okay. So let's give that a test. I'll just wipe this sort of stuff. There's all this oil everywhere. I'll re-grease this before I put it back together, if it's all working, that is. Magnet and former, or cage, or whatever you call it. Now we should test between, there's that little button there, and I guess just the general cage. Well, that's beeping. Looks like 5 ohms, but maybe that's corroded there. You can see on the end there, a little bit of black stuff on there. That might be a bit of corrosion that I might need to clean off. Because I can't really get a too good connection on there. 4.2 ohms, so that seems alright. That feels about ballpark. So what have I got? I need some emery paper just to go shk on there. Alright, I got some used 800 grit, which is alright because it'll make it nice and smooth. There's a real used up bit just to polish it. Yeah, that's looking good. Much better. Hoping that's focused. So that might give us a better connection. Way better. Yep. Okay, so I'll stick this back together and then we'll start having a look in the light itself to see what we can upgrade there. While we're here, we may as well have a bit of fun, and I'll use up some old parts I've been storing in my stack of stuff. So I'll be back in just a sec. Alright, managed to get it back together. Spring connections and all the linkages and stuff. It's all working there nicely. So next step is to hook it up. I put some molly grease in there, molly grease, whatever you call it. Just in there to make it nice and slippery. Be careful when you use this stuff. It's the black molly stuff they put in there. It gets everywhere and it stains like crazy. Make sure you wipe your hands and wipe everything before you come inside, or your wife, girlfriend, significant other will go mental. Trust me, I know all about it. So let's see what voltage we're getting out. We've got the AC volts, and looking pretty good. 5.58, nearly 5.6 volts. We've gone up by 0.6 of a volt. Apart from cleaning that little piece in there, I also used some of the old deoxide in there, just on those connections to try and keep them nice and clean, and to reduce any corrosion that might cause what we just had happening. So next step is to let's put this roughly back together and see if we get some light. That will tell us definitely if it's working. Get in your home. Are you too good for your home? Alright. Sits in there like that. Let's see what happens once I get that lined up right. There we go. Yep. We have light. Oh yeah. Not much light, but it's light. Okay, so we've got nearly 6 volts AC coming out. I'm wondering what a bridge rectifier, an LED, and a few other bits and pieces might do in there. We've got 2.4 watts at about 6 volts. So I might do some experimentation. I might hook up something and see what we can figure out to maybe convert this to an LED. Maybe like a Luxian star or something like that might go in there quite nicely. Or like a chip type LED into that little hole. That might work quite well. So I'll figure something out. I'll be back in a sec once I've got a plan. So I figured before we start with the LED conversion, we should see how much light this stock configuration puts out with a light globe. Because, you know, to paraphrase Adam Savage, the only difference between screwing around and science is writing it down. So I've got this taped up, so there's no light getting in there. It's telling me it's got 0 lux. You might be able to see, yeah, you can see it there. And if I spin it up, we'll be able to see how much light this thing puts out. About 1280, 1285 lux. We'll say 1285 lux. That's directly coupled there. So once we put the LED in, we'll put the same the same configuration, have this lux meter right up against the lens, and we'll be able to make a measurement then. So 1285 is a number. Alright, so I've figured out a workable solution here. Got the LED in there, you can see the yellow dye in the middle inside the lens, which is in the reflector. You can see the lens poking out the back there, and the LED is right there, that little PCB, aluminium PCB with a heatsink on the back. I had a spare heatsink, so I'll put that on there. But I think with the power that this thing is working at, we don't really need it. But I thought I'll put it there anyway, just for good measure. And there's a full bridge rectifier. Full bridge rectifier! Doing our conversion from AC from the dynamo into DC for the LED. I cut back the little tab. There's a brass tab like a spring that came out and touched the back of the globe in the stock configuration. I've cut that back and soldered there. And then the wire coming here is the original wire to the little clip for the power coming out. So basically what I've done is I used a tapered reamer just like this, and I've stuck that in the hole where the globe used to sit in the reflector, and I've reamed it out till it was close to the size I needed for the lens. You get these on eBay all over the place. This is a 120 degree spread. I thought that would be a decent amount of spread for the LED when you're riding a bike. I've got a whole bunch of these which I'll use them for like other projects and stuff. But I reamed it out till it was almost the right size, and I give it one scrape and test fit it. One scrape, test fit it, and kept doing that until it was a interference fit. So I just pushed it in, kind of slid in and held there with its own friction. That way it was perfectly located. Then I used the old Loctite 401 super glue that I get from the hardware store. This stuff is real good stuff. It holds real tight. Not like the crap that you get from the dollar store. It's watered down and it takes ages to dry and it doesn't hold very well. This is really good stuff. I use it all the time. So I've used that to hold the lens into the reflector. And then I've got the LED here. I got a whole bunch of these. I think I bought them from Hobby King back in the day, years ago. But you get them, eBay or whatever. But this is just like a 1 watt Luxian Star style LED. It's not actually Luxian brand, but it's that style. And just a white 1 watt LED. And they're designed actually to sit in the back of the these lenses. So that just clips on. And then I glued that in. And then I just use a super glue again to stick that that heatsink on there. And then the bridge rectifier as well is just glued on. That's not glued on there for heat sinking. It's just glued there because it's a convenient place to locate it. I soldered all the wires up, and it's hooked up, and it does seem to work. If I flick that, you'll see the LED flashing. So that will work, no worries. So the way that it's wired up inside, the way that I've done it, I'll grab my whiteboard here. So the original setup, we got the generator or dynamo. I'll put a G for generator. It came around to the light globe. And then on the nubbin on the back, that went like that. That was it. It was just dynamo generator thingo, straight to the globe and straight back again. There was nothing else. The way I've hooked it up is I got rid of that. And I put in my full bridge rectifier. I got to remember how to draw these things. I always get them backwards like that. So that's our positive and that's our negative. And then our LED is sitting over here. And we come in like that. And then we go like that. Oh, I'll make that a little bit clearer there. There. So that's it. Dynamo, generator, comes through the bridge rectifier, turns into DC, and then feeds our LED. The dynamo is rated to 6 volts at 2.4 watts. But with the load of the LED, we don't get 6 volts. At the LED, we're getting more like 2.4-ish volts, I think, or 2.6. And only about 150 milliamps. If I can write. So we're not getting much current and much voltage, so that's why I don't need any current limiting or anything, because the generator, the dynamo itself, is doing the current limiting. Not coming close to the rated wattage or rated power of this LED. So that's why we don't really need a heatsink, and why we don't need any current limiting. I also experimented with putting in a capacitor, an electrolytic. I tried 1,000 microfarad and a 1,500 microfarad, just to try and reduce the low frequency flashing when it's running real slow, because this starts pulsing a lot slower and that becomes visible. But I'll need a huge capacitor to fill in those bumps in the voltage. So the amount of space I've got in the enclosure inside here, I'll basically have to fill it with capacitors, and then it's going to be drawing the power, and you have to let that charge up before they got the light when you're reaching the right speed. It's just a big mess around. So nothing else, no capacitors, no current limiting, that's it. So let's hook this up to the multimeter and I'll show you what I mean. So I'll get the multimeter in shot, no glare on the screen there, and I'll hook up, we'll test the voltage first. I'll do it on the output side of the bridge rectifier, so we're getting exactly what's going into the LED. I'll turn that on to DC volts, and I'll wind this up. Let's see what we get. 2.6 volts. Like I said, the LED's using enough power. It's got like a low enough kind of on resistance that we're pulling down the voltage on the generator. And that's not a problem at all. We still get light coming out. It's obviously not going to be as bright as if it was running at the full power, but it's bright enough, and it's much brighter than the old globe, which was basically the whole point of this exercise. So I'll desolder the wire coming out of the generator to the bridge rectifier, and I'll hook up my multimeter in line so we can test what current we're getting. So I'll flick that over to there. This thing is only good for 440 milliamps. It's an insulation testing multimeter, so it's not really designed for high current, but that's alright because we don't have much current. I used to use this thing in conjunction with a clamp meter, so I didn't really need the high current rating on here, but I did use the insulation testing a lot for testing my installations. So let's see what we get. I've got to turn that around to milliamps, and it's AC milliamps. Let's see what we get. $180 milliamps, so a bit more than what I thought. So 180 milliamps at 2.6 volts is what we're getting, and that's enough to run that that light. Once I got it together, we'll test it and I'll show you how bright it actually is. But for now, let's put this thing back together. And that goes in there. And then no, hang on, it goes into there first. Gotta get the right sequence of events. That clicks into there. There we go. Making sure I wasn't pinching any wires. And the screw in there. And that there is done. So if I wind that up, hang on, I'll turn that soldering iron off. Not bad at all, if I might say so myself. So let's get this one out, and we'll see. I'll tape that up. I'll be back in a sec, and we'll see how much light we get out of this thing. Alright, so I've got this all taped up. It's saying 0, so we've got a good seal. There's got no light leaking in there. Auto ranging max set, so I will be able to see the maximum this reaches. So that's 377 on the times 100 range. So that's 37700. And we were getting, that's, yeah, 37,700, and we were getting 1285. Which, by my calculations here, tells me there's an increase of 833%. Is that right? That's a lot more light. Wow. It's improved. Whatever it's come up to. Well, it's on the times 100 range. Before it wasn't. It was on the standard range. Yeah. 10, 100. So yeah, that's right. We got like a 2,000% increase. That's ridiculous. Well, one thing to explain that, however, as I unwind this, is if you look at the way this is. I don't think it'd be like it does, but it do. It is the way it is because that's how it is. It's basically, you imagine with the old globe there, sitting in there, it's reflecting in all directions, like basically almost omnidirectional, nearly. So it's radiating, down this way and up this way and over here, all the way around. So that's being reflected and then it's coming out of here in a larger beam. I'm only testing from a point, right? So I was testing a little bubble in the middle, but there was light around the outside that wasn't reaching that that sensor. So now we've got the LED there, because it's coming out of a small little lens and it's more focused, that's right up close. So a lot more of the light is actually reaching here. So it's not only, it's brighter, but not only that, but we're getting a lot more light actually reaching the sensor because this is focused in a beam and this was just everywhere and focused into a much bigger beam. So it is artificially inflated. I'm not sure how much, but I am fairly confident that it is actually brighter, and it does look brighter. It does look much brighter. That's good. I am happy with that, regardless of the nuances of measuring light output. It's going to be a lot more reliable and a lot brighter, and hence it'll be much safer. So that can go back on the bike and we are done. So I'll give that a thumbs up to myself, and I'll go and stick this on the bike so we can start using it. Alright, stick around, we'll have some more videos for you and we'll see you next time.